Hi, you guys. All right, so this is going to be review for the cumulative exam, your final exam, day one. I have it broken into 3 days, so you could choose to watch them all at once or over one day at a time, however you want to do it. We needed to record them ahead of time because of the state testing requirements that's going to be conflicting with it. So if you have additional questions, feel free to reach out to me. But again, here's some problems from your review. I have 3 of these lessons, all review problems for that final exam. So let's go ahead, let's get started. So first problem, a tree is growing on a hill. In an attempt to make the tree grow straight, a 12-foot long wire is attached to the tree at a point 6 feet off the ground. The wire is anchored to the ground 10 feet from the base of the tree. At what angle is the tree growing in relation to the hill? So thankfully they gave us this diagram to help us see what is exactly going on. So they want to know what angle is a tree going in relation to the hill. That's this angle right here. That's what they want to know. They labeled everything here for us. So if I notice I have this triangle, and I'm going to name my triangle. I'm going to call this triangle A, B, C, because it helps me organize my information. So if this is my angle A, then this would be my side A, this would be my side B, and this would be my side C. And if you remember when we worked with our triangles and we're solving for a missing side or missing angle, always set up our table of information. If it's a right triangle, then things would be easy. We could just use our SOHCAHTOA. We don't know any of the angles, so we don't know if it's a right triangle. We can't do that, and we can't just assume. So if I go over here, then I know my side A, B, C. So I have a feeling that this is going to be 12, my B is going to be 10, and my C is going to be 6. What I'm looking for is my angle A. That's what I'm looking for. I have 2 other unknowns, but what I want is my angle A. So we would either use our law of sines or law of cosines. How do I know which one to use, right? Well, remember, my law of sines, if I have a full set, I can use law of sines. If I don't, then I've got to use my law of cosines. So you might have to go look up the formula again. That's okay. You should have notes. So we're going to use law of cosine. And I'm looking for an angle. So I'm going to use the equation cosine of A is equal to B squared plus C squared minus A squared all over 2BC. And I'm going to plug in all my sides. So what I end up with is cosine of A is equal to, it's going to be 10 squared plus 6 squared minus 12 squared all over 2 times 10 times 6. And I plug all that in my calculator. So again, this is just going to go into my calculator. And I get cosine of A is going to equal negative 0.067. But I don't want cosine of A, I want A. So I want to make sure your calculator is in degrees. So you want to make sure you're in degrees here. Otherwise, you're going to get the wrong answer. Your answer is in degrees, so make sure you're in degrees. So when I want to find this angle, I want cosine of A, I'm going to take the inverse of this value. So A would equal cosine inverse of negative 0.067. And when I plug that in my calculator, I would get 93.8 degrees. Done. All right. My next problem. This one is one that you guys struggle with, and I understand why it can be a little bit difficult. So let me kind of explain what's going on and where you guys make your mistake. Okay, so it says a mirror has a parabolic surface defined by my equation here. So here's my equation with the vertex at the origin. Great. And that is the center of the mirror. So that's at the center of the mirror. So when I talk about this, my vertex here is at the origin. So I know my parabola is going to be opening up. And when we're talking about, though, is some mirror. So this is the center of the mirror. I don't know what the shape is of the mirror. I'm just kind of sketching some. So wherever it is, there's some mirror, and there's this parabolic surface that's defined. And it's saying that the width of the mirror, when the width of the mirror is 8 inches, so the entire mirror from here to here. So we're using the parabola to show this. The mirror, the width there is 8 inches. Oops. That means that this is 4 inches and here is 4 inches, right? Because if it's going to be a parabola or a mirror, this is the vertex is the center of the mirror, it has to be symmetrical on both sides. It has to be symmetrical on both sides. So this is going to tell me then that my x value is at 4 here and at -4 here, right? So x is going to be a distance of 4 here and a distance of 4 here from my vertex. So the question is, when the width is 8, what is the depth of the mirror? And the problem with this, so we're talking about this x value, the depth of the mirror is that x value, but a lot of time, or sorry, that just the width of the mirror is that x value, and you guys want to use your 8 inches for that width. But we're talking about is x is going to be this value of 4. X is going to be a value of 4. You're not measuring the distance all the way across. You're here at your vertex to where that edge is, which is going to be a value of 4 to put in. So when you want to solve for the depth, the y value, how deep is that mirror? Then it's going to be y equals 1 over 24, and it's going to be a x value of 4 squared. So y is equal to 1/24 times my 16. I know that 8 goes into both of these. This is 2 times 3 times, so my y is going to equal 2/3 right there. So be careful, because if you use the value of 8, that was an answer. So if it said that your mirror was a width of 16 inches, then you would be using x is equal to 8. It's from the center to where that width ends. So it's only going to be half of that value, not the entire width. So be careful. That's probably one of the biggest mistakes. And it's a rather simple problem because you just got to plug it in, but knowing what value to plug in. My next one, it says, which conic section is represented by the following equation? Okay, so there's 2 different scenarios when determining. There's either when you have an xy term or you do not have an xy term. So if you have no xy term, then you would just need to look at your A and your C. If you have an xy term, if you have a bxy term, then you're going to use your b squared minus 4ac. So in this case, here's my A, B, and C. We have an xy term, so this is going to be where we're going. So I have that b squared, so 9 squared minus 4 times -5 is my A, my C is 5, and I end up with 81. -4 times -5 is going to be positive 100, positive 20, times 5 is positive 100, so it's going to be plus 100, and this is going to give me then 181. Okay, so 181 is going to be greater than 0. So if it's greater than 0, it is a hyperbola. So if it was going to be less than 0, it was going to be if it's less than 0, it's going to be an ellipse. Let me write this better. So if it's less than 0, it's an ellipse. If it's equal to 0, it's going to be a parabola. And this, they actually group it together, an ellipse or a circle. So they actually group those together. Why can I not spell today? What is wrong with me? Okay. If you have questions, let me know. Any of this. If you come up with other questions you're going through that you don't understand, let me know. A little bit of a variety here of things. Now we're going to trig. we're going to trig. This is probably one of the hardest ones, I think, because it contains two steps. So it says, what is the exact that, or what is the value? And so you could actually plug this into a calculator and figure it out that way. If you plug it into a calculator, most of your calculators are going to give you a decimal form, although you can easily see it's not going to be that 1/2 or -1/2, because it would be a 0.5. That one's easy to figure out. But you guys don't usually know that square root of 3/2 value offhand. Here's how you would actually work it out if you're not using the calculator. So I have my value here, and this piece is not on the unit circle. Now, if it was on the unit circle, it would be so much easier, but it's not. So also I want to point out, what does this squared mean? So let me rewrite this. 1 minus 2, this is the same thing as saying sine of 105 degrees squared. So this is saying I'm squaring that quantity. If they just put this squared here and didn't have it in a parenthesis like that, then it would be squaring the 105. We're not squaring the 105, we're squaring the whole quantity. And so that's why they put that squared with the sine value. So you know it's sine of 105 squared, not 105 squared. Okay, so here's the deal. This isn't on my unit circle, so I need the exact value. So exact value is going to be value on the unit circle, but in order to do that, I need to use my sum or difference formulas. Okay, well, sum or difference. Okay, so this is what I'm going to do. I'm only focusing on the sine of 105. So I know that sine of 105 degrees is the same thing as saying sine of 60 degrees plus 45 degrees, right? Those are the same values. 60 plus 45 is 105. So I'm not changing it. And I know from my sum and difference formula, so it's going to be a sum, that if I have sine of 60 degrees times cosine of 45 degrees plus sine of 45 degrees cosine of 60 degrees, I'm going to end up with, I go to my unit circle, sine of 60 degrees is square root of 3/2. Cosine of 45 is square root of 2/2. Plus sine of 45 is square root of 2/2. Cosine of 60 is negative, or sorry, not negative, it's a positive, is going to be a positive 1/2. Positive 1/2. Again, these are all from my unit circle. So I could go ahead and clean it up. This is going to give me a square root of 6/2, 4, plus square root of 2/4. And I could write it all as just one term like this. Okay, so this piece is going to represent this value. That's what that is equal to. That's what that is equal to. So I have now one minus 2 times the square root of 6 plus square root of 2 all over 4 squared. Ew, ugly, right? Okay, here's the deal. This squared is going to both pieces. That squared is going to both pieces. So I need to square this quantity. So if I go ahead, I'm just going to do it right here off to the side. Square root of 6 plus the square root of 2 times the square root of 6 plus the square root of 2. Square root of 6 times square root of 6 is going to be just 6. Square root of 6 times square root of 2 is going to be square root of 12. Square root of 6 times square root of 2 again is square root of 12. And square root of 2 times square root of 2 is going to be just 2. So I end up with 8 plus 2 square root of 12. You guys with me on that? Square root of 12, though, can be simplified because square root of 12 is 2 times 6, which is 2 times 3. So I can pull out a 2, so it's 2 square root of 3. So this square root of 12 is also 2 square root of 3. So I could rewrite this as 8 plus 2 times that 2 square root of 3 is 4 square root of 3. Oh, right? That's a lot. It's okay. This is one of the more difficult ones if you do it this way, but it has a lot of good steps for you guys to know. Maybe you only have a problem that just has just this piece. So just, it's good practice. It's seen a lot of different skills. This is just basic math, so this isn't hard, but yes, it takes some work. So I end up with then, so now we're gonna have 1 minus, so my numerators, it's gonna be 2. This is gonna be 8 plus 4 square root of 3. Don't forget it's 4 squared, which is 16. And if I look here, I have a common value here. 4 goes into each of these, so I can simplify it. So this becomes a 2, this is just 1, and this is a 4. So I end up with 1 minus 2 times 2 plus the square root of 3 all over 4. Not done. Look here. 2 goes into 4 2 times. That's simplified nicely. So now I have 1 minus 2 plus the square root of 3 all over 2. I need to get this broken down further or simplified further, so I need to get a common denominator. So I'm going to move up here just to give me some space. So I'm going to rewrite this as 2 over 2. Now, I'm going to also make sure to point out something here, that it's minus this quantity. It's minus this whole thing. So I could choose to break this apart. What I mean by that, I'll break it apart and show you. So this is the same thing as 2 over 2 plus the square root of 3 over 2, right? We wrote it together here because most of the time things together there because it's easier to work with overall. But you can also, this is separate and we put it together, but if it's together, you could write it separate. You could go either way. The reason why I want to point it out like this is because I need you to know that this negative goes to each piece, not just to that first number. It doesn't just become a negative 2. It would have to go to that 3 as well. This should change to a negative square root of 3. So I end up with 2 over 2 minus 2 square root of 2 minus the square root of 3 over 2. And it's easy to see that these would obviously cancel out, and you're only going to be left with that negative square root of 3 all over 2. So that was a big problem, a lot going on, but a lot of good skills used in it. And then my very last one, it says, what is the missing step and reason? So they gave us some of the steps and then the reasonings. Okay, so I look here and it tells me that I'm going from 2x to an x plus x because of addition. So what would come next? So if I have this piece, what can I do with it? And I have a sum identity. Now it's not going to be double angle. Your hint here is addition. So think sum. And if I go to my sum identities, the difference between these two was only this sign right here. So we need to go to my sum identities formula and check to see which one is correct. And the correct one is this one right here. So that's it. So these ones aren't too bad. Remember, oh, do I have it handy? Remember, you do have your unit circles hopefully printed. You're going to need those. And if you have your formula sheet that I had posted in Google Classroom, this has all your formulas together. So hopefully you'll have that handy during your final. And you can go ahead and use that. Look, here's that someone I was talking about. So this was a plus, so then it was going to be the minus one. But this has all your formulas for your trig. That is going to be needed as well as your unit circle. You're going to need that information. Again, if you have other questions, reach out to me. This is only day one. I have 2 more days of problems to go through. So you have a fabulous day and let me know if you need anything. Take care.